Hi, everyone. Thank you for having me, Sean, and organizers. This is an unusual opportunity for me as a physical scientist and really measurement person rather than a design or building person to speak to you. So bear with me, and I'm going to try to do this relatively quickly so people can ask lots of questions. I'm going to talk about California's methane emissions, and as the title says, from wells to burners. This is work that was really motivated by concern about greenhouse gas emissions from California writ large, not just methane, carbon dioxide, nitrous oxide, halocarbons. We wanted to get a handle on what the net, climate impact of greenhouse gases was for California. And my internet connection is unstable.
Ignore it. That's the nature of being here.
Okay. So I'm going to start the talk by giving you an overview of California methane. I'm not going to talk about the other gases today, except that I should say at the outset, methane is a small part of California's total emissions. By far and away, it's all the fossil fuels we burn. But focusing on methane, in overview, it, again, is not natural gas. It's mostly cows breathing and their manure being treated in a imperfect fashion. Landfills, so essentially waste management. But oil and gas is part of the story, and the emissions are generally higher than the inventories at first estimate, and that's because of a combination of really missing categories, and the people who are estimating categories often imparting biases that underestimate. That's my opinion. We have tried as much as we can to give evidence-based analysis for emissions in different categories, and I'll tell you about that work here.
Next slide.
Not yet. That evidence is going to be based on atmospheric measurements, and what that means practically is we measure things in the atmosphere, and then we infer from those measurements what emissions are, and I'll show you some examples of that from the state as a whole down to regional scales. And then for natural gas subsectors, work that we're doing and have done really, looking at individual components within a given area. That might be an individual facility, or within the facility, individual components all the way down to the burners on your stove or your gas water heater, because I'm now going to go straight to homes where I think all of you are most focused. I'll provide some summary recommendations. Obviously, we want to reduce emissions. I would argue we want to do that in equal proportion across subsectors. There may be arguments that I should learn about why that's not true in order to meet 2030 or 2050 goals. And in particular, for homes, I can't get rid of this thing, so I can't see the bottom of my slide. We want to be able to I can't steer. Eliminate unnecessary end-use losses, things like pilot lights. Although I think Jim, who's expert on water heaters, can make a very good argument that pilot light emissions, pilot lights have the benefit, if you're going to use a tank heater, of keeping the heater warm. And I'm going to show you a little bit of work we've done on on-demand heaters or tankless heaters. No, I like it like that. Unless does this mean the audience can't?
I see it like that.
So how do I turn it big? Like that? Ooh. Okay. So now slide 2. This is estimation of. I really can't drive. There we go. Estimation of California's methane emissions. Starting in the early 2000s, some forward-looking people at the Energy Commission said, what if California were to really try to clamp down on greenhouse gas emissions? How would you verify that emissions were at a given level or were dropping? And so we applied essentially an enormous, if everybody's familiar with the idea of a box model, you put something into the box, it increases how much is in the box. If you can measure how much you've added carefully, you can say, what are the sources and what are the sinks. We started doing that. We developed essentially a design for a set of towers all through California that would, by measuring the concentrations of different greenhouse gases on the towers over time, continuously, 24 hours a day, we'd be able to, with the combination of a weather model that tells us where the air is coming from, infer what the emissions needed to be to give us those signals at the towers. This is called an inverse problem. And after a decade of fussing with that and adding towers, we got to the point where we were able to make reasonably good estimates of what California's total emissions are. And at this point, our best estimate, as it says on the slide, is about 2.5 teragrams of methane a year. That's a bit more than the inventory was in 2013 when we did the analysis. And it was, to me, not a big surprise, just because, in general, with the exception of fossil fuel CO2, where we, through counting fuel sales, have a pretty good idea how much fuel gets burned. Methane has got these, I would say, hard to quantify sources like landfills or livestock or even natural gas. So when you look at the bottom picture, and I'm not going to even touch this thing for fear I screw it up, you can see a figure that shows methane source, California methane by source sector. And the largest source are livestock, combination of the enteric fermentation, that's the cows breathing out methane because their stomach is a little bioreactor, and their manure. And I will just make a comment here that the manure problem is largely one of there being industrial scale dairies that have multi-acre scale ponds of manure that are just not being treated in a careful way. And I think the state is now on a road to fixing that problem at some level. I think the same is true for landfills. We're starting to look at where the landfill emissions are coming from and designing capture strategies that are more effective. All of that is work in progress. And then, of course, natural gas. Question?
So can I take it from this graph that if you want to reduce your personal contribution to emissions, it's better to become a vegetarian than switch?
I'm not going to be able to answer that question in a thoughtful fashion at this point. I think we could talk about it offline.
And note that he said dairy farms. You can be a vegetarian and eat meat, but you're going to be going all to the milk, just like all of us has. So
if you're and you could be a vegan. I don't want to go there right now. I want to get through this talk. Dodge. So Yeah.
Does that chart represent what happened in Porter Ranch? And what is the
Okay.
Let him do his presentation.
Rob has a reasonable question, which is,
Mine wasn't.
well, because Rob's is quick to answer. I would love to talk with you about vegan, non-dairy, et cetera, et cetera. I mean, really, if we grew cows across California, I mean, grew the way we do in Marin. I don't live in Marin, so I'm. The cows in Marin are happy. The cows in Sonoma are happy. They're not industrially farmed. The Central Valley has, multi-thousand cow farms on a section, a square mile, that are industrial strength milk production. And I think that's where it gets difficult to do it environmentally consciously. Anyway, focusing on natural gas. After some of the early work on total methane, we were instructed by the Energy Commission, focus on natural gas, and so we did. We did a careful analysis of where we thought methane was coming from in the state of California in the natural gas system, adding up all the different things that we could identify, all the different gas wells, oil wells, pumping stations, and in somewhat of a departure from previous work, also said, well, we think there's probably leakage from urban areas just due to all of the homes and pipes and everything. I mean, everybody comes into their house and they go, what's leaking, right? When the plumber left our last retrofit, the kitchen stunk for a year until I tightened a bunch of fittings. So, that's the sort of thing that just happens. So the thing that we left out of that early analysis, and I think Naomi is going to talk on I've seen her slides, so I can say this, in excellent detail. Most of California's natural gas comes from out of state, sort of 85, 90%. So if there's leakage occurring at the sites of production, that's something that we didn't really think about in our early work. And I think it's important to think about that it's not just what's happening in California, it's really much broader. So just for the part that's in California, we estimated about 330 gigograms of methane a year. If you multiply that by your favorite global warming potential, and that's another issue that we can talk about for a moment, you'll get a number in CO2 equivalent units. And, this is still a small part of California's total emissions, but it's one that's really within our direct purview as consumers of energy to affect. And so we should try. The plot on the lower part of this panel for California natural gas methane shows where we thought the methane was coming from and from what subsector. And if you look here, we've got the Sacramento Valley. The red is production, the sort of greenish, bluish, if you can see colors, is transmission. And then oh goodness, Mark, I can't even read it. I need glasses. The purple is what we call distribution here, but distribution also includes end use. So that's after the meter, which is not quite the way that the word distribution is used. Now, at the bottom of the slide, it also says Aliso Canyon, and this comes to Robert's point. In what we were told was unprecedented event. In fact, there have been other major gas leaks gas spews in the country before, and I would argue there will be again. about a third of California's total annual emissions came out of one well over the course of about 5 months while SoCal Gas tried to plug it. And for people living in the Porter Ranch area, it was arguably a acute health hazard. SoCal Gas will dispute that. It was clearly something we don't want to, repeat. It's at the same time not likely to be something we experience every year, perhaps even every decade, and we really ought to go after the ongoing problem. So I'm now going to run you through, next slide, a quick look at what we found when we looked across different subsectors of California's natural gas in state. And I'm only going to touch on production very briefly. As I said before, most of California's gas is produced out of state. We did make measurements of a couple large oil and gas production areas. And we did that by, instead of using the towers, in order to home in on these production fields, flying airplanes in loops around the production fields. And by looking at how much methane, if you imagine the wind coming across the production field, looking at how much methane is on the downwind side relative to the upwind side, and knowing the wind velocity, one can integrate, this is sort of a physics problem, the mass flux of methane out of that volume. And I don't know how many people know Gauss's law, but the divergence of the flux is, the integral of the divergence of the flux is the source term. So we did that again and again for different places, and I'll show you that for a bunch of different facilities, but we did that for one oil and gas field, and then in a separate study did it for a couple of gas fields together. And we did not find that the numbers differed enormously from what we had estimated for those fields based on the number of wells. I will stop there and just say those were snapshots in time. They were not representative of the average. And I think that the studies that Naomi will talk about for the out-of-state were done much more persistently and effectively. Now, we did the same thing for natural gas storage. This is the next slide. And here we found that emissions were, and this is work that we did not do, my group did not do by ourselves. This is really a summary of work by several different groups. In particular, the Jet Propulsion Laboratory did a series of airborne imaging flights, which essentially take snapshots of what the methane plume looks like leaving a facility, and again, using winds, can effectively integrate how much methane is coming out of the facility. Combining work from our airborne study with that, the California Council for Science and Technology concluded that there were about 10 gigograms of methane a year coming out of natural gas storage facilities, and that's 2.5 times what the current reporting for those facilities is, with really just 3 of the major facilities dominating that emission. So, and this does not count the failure at Aliso. The failure at Aliso is sort of 10 times that, or about 10 average years of storage worth of emission. Continuing on, next slide, methane from petroleum refining was even more egregious. We found from, again, unfortunately, a limited number of flights over 3 refineries in the Bay Area, more than an order of magnitude more emission than those refineries were reporting to either US EPA or CARB. And we haven't had much comment from the refineries about that. I'm both really curious, were we right, or did we have some bias in our measurements? For example, the refineries only emit when we're flying, No, I'm not joking. If you want to mitigate the health effects, thank you. If you want to mitigate the health effects, you want to make your emissions occur when the air is well mixed. And we fly when the air is well mixed, you know, during the hot, convective part of the day. So I wait to see, you know, whether we were right about this. But well, the problem for us is that we can't fly at night. And that's the time when you have the least convection. And I'll just stop there because I want to get through the talk. So we've done, then this is the next slide. We attributed methane in the Bay Area to different sources. Here we combined with extra tracers because I dawdled at the beginning of the talk. I'm now going to go too quickly. I'm just going to say by using these additional tracers, we can say how much of the methane is from natural gas versus biological sources. And we found that the vast majority of Bay Area methane comes from biological sources. Here, primarily landfills, because the Bay Area has got a lot of people and all that waste goes somewhere and it makes methane. However, the natural gas is clearly measurable and it appears to slightly exceed the inventory as we had seen before. We are suspicious that that is not just leaking pipes in the street. We think that that has some substantial part in homes. And so we've done a study on homes. I'm going to skip now 2 slides, one quantifying roadway emissions, and then one that says localized plume measurements. And the reason I'm skipping those is that I'm short on time. The bottom line of both of those slides are we've driven cars set up with the same sort of measurement instrumentation that we used for the aircraft around urban areas, and we measured plumes on the roadways. We don't know exactly where those plumes are coming from often. It could be a leak in a pipe in the street, or it could be, in the case of Bakersfield, which I highlight in one of these slides, oil and gas wells that are not being, you know, plugged properly. But I'm going to focus now on homes. And so this is the slide that says California residential methane emissions. Here, what we did was to depressurize the house with a blower door that's used to measure the air tightness of the house. I will assume everybody gets that. And then we measured the indoor concentration of methane relative to the outdoor, and assuming that the house is reasonably well mixed at the blower door and that we've gathered all the leaks by depressurizing the house, we can estimate how much methane must be added to the house if we know the ventilation rate. And when we did this for about 80 homes across California, we found that there was a lot of homes with very little and a few homes with a whole lot. And this is the sort of classic example of long tail distribution. It's not normal. It's sort of even beyond log normal. And
the one bar to the left of 0 on that
yeah, the bar on the left is noise in our measurement system giving us negative values.
It's not houses absorbing methane.
No, it is not houses absorbing methane. However, I will give you, there is one place where we have seen methane absorbed by a house, and I'll talk about that in a moment. We did tests whether this technique worked using calibrated releases of methane. We also tested whether the methane we were observing was biological by using the C13 isotope of methane. If you want to hear more about that later, we can talk about it. Long and short of it, most of the houses were less than a gram a day of methane, though a couple were more than 10. A few were more than 10. And we then looked at the combustion appliances. And the one I'm showing here in this figure is a tankless water heater. And the reason we focused on in this slide on tankless water heaters is that you get a very, very clear signal of methane from the tankless heaters. So it sort of illustrates the point. Here what we do is we measure the ratio of methane to CO2 in the flue gas and assume that the CO2 is representative of how much fuel is being combusted. If we also measure how quickly the meter is spinning, we know how much fuel is being combusted, and we can convert the methane from that ratio into an absolute methane emission. One of the things that we found here was that most of the heaters have, this is both tank water heaters and cooktops, have less than 0.1%, down as low as 0.01% of their methane being emitted without being burned. In fact, we found, and this comes back to the point about absorption, we found that very efficient, what you call them, forced air furnaces, these 94% furnaces, condensing furnaces, actually consume not only the methane that you're putting into them from the gas, but also the methane in the ambient air that you're supplying as, as combustion oxygen. In other words, the methane coming out of the heater was lower than ambient. We were going, did we do this right? And so we checked it 5 times, and yes, in fact, these things are combusting more than just the fuel you put in. They're combusting the methane in ambient air. This was a big surprise to us initially. I now learn that large natural gas-fired power plants often have plumes coming out of their stacks that have methane less than ambient air. So I learned something. The thing that we found with these heaters, 1 minute, are that those heaters often are very low, but occasionally burn very poorly for reasons we don't understand. We didn't have time to, essentially exhaustively examine all the heaters. We found that some had more than 1% of their methane emitted unburned. And that is not so good. I should just say here, and I should have put this in the introduction, here is a round number that everyone can take home. On a 20-year time scale, methane emitted at only 3% of the total gas that you're using will double the effective warming caused by the other 97% of the fuel that's combusted to CO2. In other words, you get equal amounts of warming from the 97% that is combusted to CO2 as you do from that only 3% that goes uncombusted. So you really care about leaks at even the few percent level. Okay, one other point about the tankless heaters. We notice that when we turn them on, you get a little puff of methane that doesn't quite get burned. When you turn them off, you get another little puff of methane that doesn't quite get burned. So we found that starting and stopping tankless heaters is actually a real problem. And so, if you're like me and, you're trying to conserve water and fuel, and, you turn the water on for a little bit, you turn it off, you turn it on, you turn it off. Each one of those is giving you a hit of methane that you don't want. And so I've got 2 tankless water heaters in our 2-unit house. I've gotten to the point where I fill a bowl of water with hot water to do the dishes, and then I wash with that, and then I fill it again to rinse. And, it's very different from having a tank heater. You got to think about it differently. Okay, so in summary, the preliminary estimate of combining all of this, sort of whole house emission, which included the pilot lights, by the way. We didn't turn off the pilot lights when we were doing that test.
But they're outdoors. The combustion air is outdoors, and they're vented to air, so a blower door shouldn't catch them.
Blower door depressurizes the structure, and so any interior water heater is going to be part of this blower door measurement. And we did not operate any of the appliances during the blower door. That was only the pilot lights. So Jim is making a point. We may not have caught all the pilot lights that were in water heaters external to the building, and even in a garage where we don't effectively depressurize. I mean, there are caveats to the study. It's not perfect. Long and short of it, about 35 gigograms a year of methane. And sort of to put that into the quicker, easy to use perspective, that's equivalent to about 0.5% of total consumption we believe is leaking leaked. And that's got a sort of factor of 2 error on it. It could be half of that, it could be double that, round numbers, because we don't know everything well enough to say much better. But that gives you a starting point for understanding methane. Okay. Summary recommendations, and then I'll stop. Total natural gas, probably 10% of California's total methane. And remember, the cows and the landfills are the big deal. The residential emissions, about 0.5% of the consumption. There's studies now focusing on commercial buildings, industrial buildings, San Joaquin livestock, etc., that are going to improve these estimates and be more specific. In terms of recommendations, being a total novice, I'm just going to throw out some recommendations that I want you to slap them down because I'll learn from that. We should standardize requirements in both retrofits and new construction for leak detection and repair of natural gas pipes. I mean, it just makes sense. You can now buy a $150 leak sniffer that squeals if you get it near a leak, and people should just do that and not have leaking pipes in houses. We should do better on natural gas, methane burning appliances so they don't have the problems that we're seeing. And ultimately, we should go to no more natural gas. I mean, no more fossil natural gas. Thank you.